So yeah, the question kind of how do we represent multiple objects when we start learning variations of familiar ones, or as you kind of mentioned in the document, suddenly you have a subpart of an object like the stapler top.
Yeah.
But yeah, so I don't know, do you want to start?
I guess, yeah, I can just start walking through that. This is a topic that was like really confusing for me. Um, yeah, and I worked on it last week. I don't know if you remember, we were exchanging some messages on Slack, and I just felt like kind of lost thinking about it. So then I said, well, I'll just sit down and hunker down and try to come up with some ideas. And so I worked on it the last couple of days. And it ended up something pretty simple. So I'm not sure what I'm missing. But it's not a complete idea either. It's just like, at least it's sort of a grounding in which to build upon. So I wrote that up. Some of you may have seen that. I put it in Slack. I can share my screen and bring it up and just walk through it, if that's okay.
Yeah, sounds great.
Okay, I'm now sharing. And I want to bring up Slack. And I'll just bring up the document I posted in Slack. It's up in the research beam. This guy here. All right, can everyone see that?
Yep.
How do I get rid of this? How do I share so that crazy thing? Okay. So I just sort of started wandering the wilderness, thinking about all the things we've been doing and trying to make some sense of it all. And so, we have all these variations on models that we've come up with since the original idea was like, hey, there's a reference frame and there's a location. You have a sense and you put some information at some location, a reference frame. Hey, isn't that wonderful? And then it gets really complicated. So we've talked about morphology versus features. And I don't think we've ever completely resolved all that. But the idea that you can build models that are just, you can recognize things just on the orientation or the edges of models. And then we've done a lot of work on compositional structure. We've done a lot of work on object behaviors, which we've now broken into sort of separate models. And then we've had this whole classification, this whole area of classes of objects, which I think, Niels, you might have been the first one to bring up, but we never really resolved all those either. And so those are variations of objects that are similar. And so if I see a new class of an object, it inherits some properties from previous objects in that class. And so there was a common theme over this is that that we end up to splitting models. I use the word splitting. I don't know if that's the word you guys use. I forget. Where we have a model and then we have to create a new variation of it. We want to maintain a lot of the properties of the first model, but have a new model. And the most important thing is we can't relearn everything every time we form a new variation, whether, any variation. So, and then we first got into this in a big way with the stapler, which we have a lot of good figures, which I'm not showing here, but how do we learn that we never saw the stapler open, then we see it open, then how do we model the different parts of the stapler when before they were the same? So hopefully you all remember that. And then at the point was we're running into similar problems with the with composition. And there's two ways the composition problem works. There's like a feed forward way and a feedback way. The stapler was a feedback way in some sense, like I start with an object, I'm splitting it into components, child objects. And the other way, the feed forward way, you might think of it as I take two objects and I'm trying to create a new object that I didn't have before. So when you're building new things and one is you're splitting something apart. I also wrote here, the problem I saw, we had this basic idea. Let me just see what I'm reading my text here. So when we talked about the mug and the logo, let me read it right about here. We had this idea like, oh, how do I know I have a mug and I have a mug with a logo? And we said we might have some state variable which says, oh, this is a regular mug. Oh, no, this is the one with the logo. And then internal to the model, we could say, oh, if I know the state variable says there's a logo, I make one set of predictions. And if it's one without the logo, I make a different set of predictions. But other than that, they're the same. But this doesn't work if there's a lot of variations of the other things. Just this one thing like a logo, yes. But I came up with lots of variations where you could have multiple things. I could have mugs with logos and without logos. I could have mugs that are tall and mugs that are short. Some could have logos, some could have no logos, and so on. And so a single state variable wouldn't work, and we can't have lots of state variables in a column. There's just not possible. So, and then we also have
When you say
question.
we can't have single state variables in a column, as in,
We can't have many state variables in a column. We could have one. Like if I say, okay, mugs come in tall, short, green and red, the blue lips or no blue lips with the Meta logo or with a Thousand Brains logo, and I can have any one of those flavors, then a single state variable is not suffice. I have to have a state variable for each of those particular variations. And so I'd have to be able to say, oh, this mug is the red one and a logo, and I can make predictions about that. Or this one's the green one without the logo, and I can make predictions about that. So the idea that there'd be a set of cells within a column, I'd have, if I have some cells that represent a particular variable, I can't mix them. I'd have to have separate sets of cells for those. Otherwise we get back into this, mixing of SDRs anyway. So it just felt, and then,
okay,
and then I came up with another example. This one down here. Did I answer your question, Neil, sufficiently, or did you?
I mean, yeah, I think we'll get to it later in terms of the top-down feedback stuff, but it feels to me like you could have a single population that represents multiple different states,
It could, but
and then there's some limitation to how much superposition of those states you could have.
Right,
but
right.
But yeah,
it's not a general solution either, because as we saw with the stapler, there was information that had to come from the R2 to tell the R1 how to divide the object into two parts. So in the case of the stapler top and the bottom, we saw that there had to be a signal from another learning module telling, so there was an example where internally you wouldn't have enough information to know that the stapler should be broken into two parts. Someone had to tell you that. And then I gave up this example here where I started thinking about time, and where like you can have a temporary arrangement of features. So that's the thing, imagine the mugs on a table, and you want to remember where it was last time you saw it on the table. So that's a temporary compositional object. Our mechanism should work for that. But then I realized, oh, but I might remember where it was this morning or yesterday. And so I have the same basic components in a different arrangement. And I have a model of that too. So the only difference between those two is time. And so I don't expect that time variable to be located within the column. And then I said, well, what if every day of the week the mug was on a different portion of the table? And so that have to have day of the week would be the variable that I would use to make the correct prediction about where the mug is. And that too is not something I would expect to be in the column representing mugs or tables.
right.
So there could be some variables within a column within the learning module. But clearly that's not the general case. The general case, I have to have signals coming from elsewhere. That at least there's examples, many examples of signals coming from elsewhere that would tell me how to different, which model should I be invoking right now? Is it the model where the cup's in the middle of the table? Is the model cups on the one corner? Is this the, that kind of thing. So I just went and assumed, I went all full on to this. I said, well, how about I just assume that it's always an external state variable? That could be wrong. But if I have if I assume there's external state variables, then I can have as many as I want because they can be coming from different places. That's broadcast broadly in the cortex. So, some could be broadcasting time, some could be broadcasting day of the week, some it could be, under any context, I might say, oh, when I'm in the living room, the mug is always on this corner of the table. When I'm in the dining room, it's on this other corner of the table, that kind of thing. So there could be almost an unlimited variety of contexts in which you would make different predictions on the same objects or similar objects. It just felt like that to me.
Yeah, and that would kind of match with the way we talked before about how a state could be this broader layer one input that gives context and basically conditions which features to expect at what locations, but while still using the same reference frame in layer 6.
So maybe I came right back to where we were before, but it certainly wasn't obvious to me in the beginning as I started going through this. I got clarity going through those examples. So before I came to a simple conclusion, and you have something else you want to say?
I can bring it up later.
Then I also thought about classes of objects. This is something that it bothers me every time I bring it up because I really had no idea about it. And we never really resolved like what's what makes a class and how would I differ, how do I know when a class and how do I, and then I said to myself, well, if I have, let's say, let's just jump right into it and say, what if my reference frame anchoring, that is the reference frame is anchored, that is the class. And I can have as many variations on that as I want. And so as long as I anchor the same way, then it's the class of objects. That class of objects could consist of one object. So I could say, oh, I'm in this room, and that's, I've anchored to this room. Or I could say, oh, I'm in a room I'm in a kitchen, and that's a class of objects, and therefore I have a bunch of different kitchens I know, and but they're all anchored the same way, that kind of thing. So it's like not all rooms would be unique. It would be like if there's nothing common, I would say, yeah, this is the class of other that I had before. So this idea that you essentially say, okay, the definition of a class is a particular anchoring of the reference frame. I may have one or many specific models in that class. Those models actually don't even have to have anything in common. I could still say they're in the same class. I always used to think it's funny how when we start to think of what's a fruit, and then you tell the child thinks of all the things that they think of fruit, and then you tell them a tomato's a fruit, and they say, "Wow, that doesn't look like a fruit." And yeah, well, it is technically, it's a fruit. So you can say a tomato's a fruit. It's in the same class, maybe, but that's a stretch example. But my point was, if you just take this idea, once you say anchoring of a reference frame as a class, then you can have any kind of models in there that overlap or don't overlap a lot, or just have slight changes or not. It doesn't really matter. There could be lots of different variations of things that's in that class. I don't know if that works, but that's the way I was thinking about it.
Yeah, I like that general idea a lot, actually. But I was wondering, so when you create a new state of that particular object, can you still reuse the data that's stored from a different state? Like, for example, I've learned the mug without the logo, and then I create a different state of mug, which is mug with logo. Can that model, if it basically doesn't store things for the locations where, I don't know,
Right.
the handle is, go back to the
I think of the way I look at it is at any particular location, there is something stored. And then sometimes you can, under different states, you can store different things at that location. So I can have a very small change and everything else is the same, right? I can say, oh, this is the mug that has the nick in the corner, the little crack in the corner. And so, okay, so everything else is the same, but when I get to that location on this one, I'll make a prediction that's different and only in that location.
Yeah, so it's more like
So,
there's a default and then the state can change specific parts that are different in that state.
right. So
Yeah.
the default assumption is you keep everything until you start adding something else. I thought about this with the stapler. I mentioned it in here. So I have no good figures for this, and you just have to listen to me rambling. When I realized the stapler, we would draw the stapler sometimes as if it was just a big rectangular box and featureless, and you couldn't even see the seam. And then it opens up, and voila! Now you see that it's two parts. So I was imagining, like, when you open up, well, then sometimes you see things you didn't see before. Like there's new features you can see under the bottom of the top, and there's new features you can see under the top on the top of the bottom. And so you'd want to add those features to those models. So you'd start out absorbing all the things you had before. The stapler top is still the staple. There's still these features in this area of the model. And now I can add new features only to the stapler top, and I can add new features only to the stapler bottom.
I was
That's the
actually,
general idea.
yeah, I was wondering if it makes sense to apply the same mechanism to the stapler, because it seems like it seems kind of fundamentally different. Like, I wouldn't say the top and the bottom are two different states of the stapler. I would say like where the top and the bottom are relative to each other are different states of the stapler. but
Well,
the parts
wait a
seem,
minute. I wouldn't say the two different states. Imagine I say they're different. They're all in the class of stapler. So the stapler could be a complete stapler, or it could be a stapler top, or it could be a stapler bottom. But in my definition, I would say they're all in the class of stapler. Using the word state is a little misleading. That's right.
I guess, yeah, the thing that feels weird about that to me is that as you see the whole stapler, you perceive both parts. So you're basically perceiving both states at the same time if the top and the bottom are two different states of the stapler.
right. But I wrote in here someplace. I don't know where I wrote it in here. Here we go. Right, this paragraph here, I think. Whoops. Where's it? Rich talking.
And especially if they share the same reference frame, then that's kind of odd if the bottom of the stapler is not rotating and moving.
So here's I suggested this. I said you might no, this is not the paragraph. Where did I say this? Oh, right here. I said you might have three models of the stapler in R1. You have the original one, and then you have the one that says, oh, we're paying attention to the top, and you have another one that says, oh, we're paying attention to the bottom. And so I didn't see why the original complete model would go away. So
yeah, I would.
Does that still bother you?
Well, that sentence I would agree with. Like I would think of it as R1 having three models of the stapler, but I wouldn't think of them as being three states of the same model that share the same reference frame because they're moving independently, and like one
Well,
part
first of
is
all,
rotating.
they're not the same model. There's three models, but they have a shared reference frame. So they're all in the class of stapler. In fact, if I asked you to identify one, you'd immediately identify any one of those three models. If I just saw the top or the bottom, you'd say it's part of a stapler, right? So you know it. But so what's the problem with that?
If they're sharing a reference frame and you're perceiving
Yeah.
them both at the same time, how can the top part be rotating while the bottom part is not moving?
But then you wouldn't. Then you'd only be perceiving the top or the bottom.
So that column would be. Yeah, it's interesting. Yeah.
Yeah, R1 would be, you'd be attending to the top, and R1 would, in some way, I don't know yet, the context would tell it that we're just dealing with the top model and pay no attention to the bottom model right now.
Yeah, I guess I was thinking of like the kind of child object segmentation as you see them move as being maybe a different type of process where you have originally learned the full stapler model, and then as you see them moving, some of the parts the model isn't predictive of anymore. So let's say it has anchored to the stapler top, and so the reference frame is rotating with the stapler top. It stops being predictive of the bottom features, and so it slowly forgets about those. And then there might be a different.
Well, wait, why do you say it slowly forgets about them? It's not going to forget. It's just the context says we're not paying attention to that model right now. The context, by the way, one thing I didn't say here is that the stapler example gave us that it wasn't, there was this idea also that the context would occlude some parts, right? We required that in the stapler example, that the context was not just, oh, we're stapler top, but the context says, there was a context that says only pay attention to this part of the model.
Yeah, I mean, for what it's worth, I had a similar thought when I was reading this, that specifically for the stapler subdivision part, that feels like a different mechanism. And I feel like part of it is just kind of how fast it happens, that it's kind of like as soon as you see something moving independent of other things, you can kind of segment that out. And it feels like that happens almost like the whole object, which kind of fits with, I guess, what we've talked about before, the kind of type stuff.
Yeah, but
whereas
I can't.
It feels like when you're learning this new stuff, that's more like you attend, then you learn a point of new information with that context signal. Then you attend, you learn another new point of information, like, oh, okay, there's another logo here.
I'm missing this distinction that both of you see. So I'm a R1. I have a model of the stapler, and now stapler top moving. Our assumption before was that a signal from R2 points out that, hey, there's a subset that's moving here. And there had to be some sort of signal that says attend to this area of your model and don't attend to the rest.
Yeah.
And that to me is either it's part of the context that's being provided to R1. It may be the entire context that's being provided to R1. It's interesting to think that the context may be thought of as an occlusion area or an area of attention. I don't know. But anyway, it's at least part of the context. So in that case, as soon as we do that, we have to be able to add new features to the stapler top that we didn't see before. So I have to have a new model that I'm building at that point.
I have a question. So, sometimes a child object needs to be part of two different classes of objects, like a table leg, or it could be part of like a table or a chair or something like that. Does that mean for that leg we would learn two objects because they have to anchor it differently now?
That's a good question. Yeah. That's interesting to think about.
Yeah, I think that's another good point. Like I don't know, to me I'm still on board with the like temporary masking and all that. It just doesn't feel like it's a different state of the same object. It seems like maybe at first it is exactly the same object and we're just applying a temporary mask, but it seems like it's a different problem to segment an object into child objects versus having an object and different variations of it,
Well,
like
well,
a class
it may
of
feel that way, but let's just walk through it. I mean, on the one hand, we know that we have to keep the features in the same reference frame for the top of the stapler, because otherwise we wouldn't be able to make predictions about it. So even though I'm isolating the top of the stapler, I have to maintain the original model, right? I mean, that has to be there.
Yeah.
And now I need to be able to add new features to that model that only attain to that subset. And so it seems to me I have to maintain the same reference frame. I have to be able to differentiate it from other instances of models in that reference frame. So I've just stated some what I consider points of fact, or at least statements of making. And so that feels to me the same. How's that feel different to you? I don't.
Yeah,
or
Can I give a different example instead of stapler? Like stapler
Should
top
I
and
stop?
bottom.
Excuse me. Should I stop sharing my screen? I don't know if it's helpful to have me.
sure. Yeah,
It's
we
up
can
to
always
you.
come back to
Yeah.
the document.
Yeah.
Okay.
So maybe like bicycle. So if we like a stapler top and stapler bottom kind of feels like it belongs to the model stapler. But for bicycle, if we segment out, for example, everything except for the wheel, like I wouldn't say wheel is like a wheel feels like a different model from bicycle.
I think it
that should
is.
live
In
in a
fact,
different reference
I
frame.
do. I think you're right. And because if
Okay.
I see a bicycle the first time, I don't know why, but it feels like I would not think of this as like a monolithic thing. I would look at each component and try to understand what it is. And I probably have seen wheels before, and I might have seen pedals before, and things like that. That to me is more like the mug and the coffee cup, where we're taking individual things we already recognize and building something new. But the thing with the stapler, Jose, we were able to imagine a stapler looking at just like a rectilinear box with no delineation, and also magically it separates, and now you see things. So there's no way in advance to know that there's two parts. With a bicycle, it doesn't feel that way to me. So I wouldn't learn the bicycle like one thing. It would always be multiple things to start with.
But I'm not sure. I mean, I feel like you usually see the full bicycle before you see all of the parts of it individually.
Yeah, but the way I think normally what happens is when I see something I don't recognize, I immediately I keep narrowing down my attentional focus until there's a part I do recognize. I always do that. Like if I never saw, I see something, I don't know what it is, a new kitchen gadget or something, I will then keep attending till there's here's a blade, or here's a screw, or here's a handle or something. I always keep, and then I start building up a compositional structure. The staple example was different because we can imagine the basic staple having no differentiating components. It was just a box. But that's not the case usually. Usually I think we would, if I see a new word, I don't learn the whole word. I go down and look at each individual letter. And if I don't recognize the letter, I'll look at the features of the letter or something. Same thing, a bicycle is more like that. You wouldn't learn the whole thing. You keep attending till you find something you do recognize, something basic, and then another, and you build it up compositionally.
But it still seems like generally we would want child objects to be their own objects and then be composed
Right.
into a parent object instead of child objects being different states of the parent object.
No, I agree. That's what I'm saying. That's what would happen. In the bicycle example, all the components of the bicycle would have their own reference frame. And then we would be building a compositional object from them. Right. We're going in a feed forward direction. We're saying, oh, we have all these individual models. Now we're going to build a compositional model that it's basically positioning all these child objects relative to each other. That's why I was trying to make this distinction between feed forward and feed back. Where the stapler, we had something we thought was we didn't realize could be divided at all, and then it got divided, and we had to figure out what was going on there. And it's in some sense a different problem or a different solution. So yeah, I agree. All the parts of the bicycle would have their own independent reference frames because they're all independent components that you would have learned separately. And then
Maybe the stapler is more of an edge case that doesn't really use the mechanism we want to be using, or maybe it would require having to relearn individual models of the top.
Maybe
and the
I
bottom.
don't think so.
Or is it kind of a short versus long-term thing? Like, yeah, initially you develop this child object representation. Whether there's a context signal or not, it's still like taking a full model and kind of just looking at parts of it.
Well, that's interesting.
And I think that could happen with like anything, like even like you could have a new tropical fruit you've never seen before. You learn kind of a model of that just by looking at it. Then someone slices it in half. Now you see the new insides of it, and also half of it has been taken away. And so suddenly you have this half of an object that you can kind of almost instantly perceive as this. You still think like, oh, that's that fruit now cut in half.
Right. Well, it's like right. Or if I see the top or the bottom of the stapler, I still say it's a stapler. If I see a wheel, I don't say it's a bicycle. I say it's a wheel, and it could be on lots of different things. It could be on a little trailer, or so it suggests it might be on a bicycle, but I don't say, oh, that's a part of a bicycle. That's a wheel.
But I wouldn't say that the bottom of the stapler is a stapler. I would also say it's the bottom of a stapler.
But it isn't anything else. It's not part of a bicycle.
That's maybe the intersection of the state variable or state representation with the reference frame is like, okay, that's bottom of stapler.
I didn't follow your comment.
As in like, yeah, I agree. It's something you can uniquely define, but it's maybe that unique definition is the intersection of the state representation with the reference frame. That's what makes it the bottom of the stapler or the top of the stapler.
Right.
As opposed to, you're not saying someone doesn't give you the bottom of the stapler and you say this is an entire stapler.
No, you don't.
But it's still kind of grounded in your representation of stapler.
Right. If all I could see was maybe I was looking through a straw and all I could see was some features on the bottom, I say, oh, that's a stapler, and then I see a feature which is only exposed when the stapler is open. Then I say, oh, that's the bottom of the stapler, and the stapler is open, or the top of then I would switch to the context of I'm only looking at the bottom part. I think it works out well. I don't see this as an important distinction. I can see where it's coming from. Essentially, it's possible. I think you capture it, Niels, on different words that I would use. If I take something that I know is one object and I divide it into multiple pieces, those multiple pieces are still classes or parts of that object. You know, they're not something else. It's not like a stapler bottom doesn't appear on my bicycle. You know, I could try to make that happen, but it's still just part of stapler. And so there's that's where you're going. That's the feedback one, where you're taking something that you know is one thing, and you realize that there's independent parts of it that you didn't realize. But that assumption there is that they're all still part of that. They're all still stapler parts. They're not like all of a sudden completely different objects. And you would immediately classify any one of them as part of a stapler. Whereas if you go in the forward direction, I have a logo and I have a mug. I now create a new. I now take the mug and I say, oh, under certain contexts, there's a logo here. In certain contexts, there's not. The logo and the mug are not part of the same class. They don't share reference frames, and it's just different. But I think the same the feedback and the feed forward are different, but the same concepts apply. I guess I'm trying to solve both of these at once.
But the first
Yeah,
time,
and maybe with long term.
okay.
I was just say, yeah, and then maybe with long term, you would learn like a totally separate reference frame, particularly if you see that child object in different contexts. So you see wheels in different contexts, and then that's when you start. Like, I wouldn't be surprised if when a child first sees a wheel on a bicycle, they kind of understand that it's moving. It's kind of this separate child object, but it's also kind of like it's not a concept that exists beyond bicycles. If they've only ever seen it, if they've only ever seen it in that context.
Maybe. I don't know, you know, in reality, they would have seen wheels elsewhere, almost certainly. And it's possible what you said is true, Niels, but it's also possible that children struggle with things initially in their life, understanding what they are. And it's possible also that they just really can't conceive of a bicycle very well until they understand the components. It's harder to, you know, this goes back to the theory about how a child learns to read. Should they learn to read by looking at whole words, or should they learn to read by looking at letters? And there's these, you know, two schools of thought on this. I was brought up in the era when you learn letters first, then you compose them into words. But that's the way I think about it. It's more like, oh, I'm not going to really learn words until I know letters. And if I saw some pattern, but I could, under different contexts, I could learn a whole word as a thing, and then later try to separate out the letters.
Yeah, well, like I noticed when I was trying to learn some Sanskrit that I was kind of doing both. So I would obviously try and learn the letters and focus on the strokes and those. And then if I was learning a new word, I would try and focus on each stroke to recognize the letter, and then recognize a series of letters to be like, oh yeah, that is the word. But I also had like a coarse model of the whole word. And I could often just match that because it kind of had like almost a shape, quote unquote, that sort of looked familiar. And I was like, oh, that is the kind of shape of the word for man, and that's the shape of the word for woman.
We do that too.
So it feels like both was kind of happening at the same time.
And we do that in English or any Western language like that, where, you know, when you read, of course, you don't even see the letters, you just see the words pretty much for the whole part, unless you get to a complicated word and you might have to, one you don't know very well. But we don't look at letters. This is why people can swap out letters in the middle of words and you don't even notice it while you're reading it. As long as it's the right basic shape and the words, the right length and so on, you won't even notice they change anything. Well, I think these are just, I don't know, to me, these all fit into, this is the right conversation to have, I think. It's like, okay, sometimes we have to take things and break them apart. I'm arguing and we break them apart, which is not the most common way we learn. Then we break them apart and we have these components to share a reference frame. If we're mostly what we do is building compositional objects where we take things we already know and bring them together. But we can do both, right? We can learn, as you said, learn the words as an entity as opposed to just a compositional structure. I don't know what else to say about that.
Yeah, to me it still seems odd to talk about components as different states of the parent object, because like how do you know that the stapler bottom is not going to show up in different objects the first time you
Well,
see?
well, first of all, we know that we can deduce that initially the stapler top and stapler bottom have to have the same referencing. If not, you wouldn't be able to recognize them. You wouldn't be able to make any predictions about them.
Yeah, but
That
then
to me-
why, like, it could just stick to the part that you keep following, and it just learns more about the stapler.
Well, then I said, oh, but as they become separate, then I can add new features independently to them. That was the point of saying, oh, I can now see under the stapler top, there's some extra things that I couldn't see before, and they become now added to that version. First of all, I wouldn't say these are just states of the stapler. I'd say there's 3 models in the class of stapler. There's a subtle distinction, but I think it's an important one. It's not like, oh, there's a base model and then there's flavors of it. It's like, no, there's 3 models because they all share the same reference frame. And let's say there's a context for all of them. And on the one context, we have a whole bunch of features. In another context, you have some of them are shared and some are new. In another context, other ones are shared and some are new. I even put this in my little write-up. I said, when I'm learning something new, like a new object from the start, should I assume that there's context for that? That is, when I learned a stapler for the first time, it's not like the whole stapler is somehow superior to the components. It's just another class of object in the same reference frame anchoring. So
But I guess
turns
it's
out
more parsimonious if you do assume, because that's kind of the topic earlier. Like it's more parsimonious if you do assume some kind of superiority by that being the original learn model. Because
why
like
is that?
if I have a model of a mug and I just learned that, and then that's maybe there's some default context, but it doesn't really need to help predict anything because the reference frame can predict everything. It's almost like the context is just needed when you deviate from that. And so now if there's just like a bit of color here.
Right. That was my assumption too.
That would be like
But
the one association. But then it's weird if like the original context needs to kind of learn for every point, like adding information that the reference frame already has.
So I've taken this one step further in my mind, and I said, just assume there isn't some sort of master object. The only thing that matters is anchoring the reference frame, right? And now just imagine, if I'm just going to state this, after we've done the stapler, I have an anchoring of a reference frame, and in that there are 3 objects. And you and I might say, oh, one's the complete stapler, and one's the stapler top, and one's the stapler bottom. But the system doesn't know that. It just says there's 3 objects and any of those objects could share any number of features and have any number of unique features. It just turns out, and
Didn't we just earlier say that there is a default object, and then in the different states we only store the deviations from that? Because otherwise, every state has to relearn everything again.
No, it doesn't.
How would it know where to look up the features
feeling.
that are not stored in that different state?
Mm.
Wouldn't it need to look up in the default state?
Okay, I'm trying to make it work. So let's just think very generically about models. You got this reference frame, and you get to some location in the reference frame. What we're suggesting, under different context, you would predict different things. And then we said, and you're arguing without any context, it would be a default. And I'm trying to get it to work where, and I think this is a more powerful solution, is if I could get rid of the idea that there's a default, that there's just 3 models. And how would that work? I can see the problems of it. I still like the idea.
I agree that. Sorry, what did you say?
What would be the advantage of there not being a default?
Well, yeah, because I agree that it's nice that we don't kind of like magically assume the complete stapler is the prime model or whatever. But I feel like that's not an insurmountable issue in that like it's either, you know, a mixture of like what was learned first plus what is most common, and that just becomes kind of the most represented model. It's not that it has some
Okay, let's
kind
say
of
I have
special
two.
significance.
Let's say I have a mug, and now I learn another mug, which is exactly the same as the first mug, except it's an inch taller. Everything else is the same. I don't want, you know, I see that new mug. It's gonna inherit a lot of properties from the old mug. Some of those properties are location specific, some are not. Like it'll inherit properties of like what its affordances are, how it will behave physically, its temperature and so on, its fragility, how it might break. I might also say, oh yeah, this is just a mug in the same series. So if I go on the bottom, I'll see the mark of the person who made the mug. So I expect to see that. So those two mugs, in some sense, are very, very similar. And even though I learned one first and then I learned the other one second, I'm not sure I feel like one is a primary and one is a variation. It's like, oh, these are just two flavors of mugs. And yes, I learned one first, but does that really matter? You know,
You don't
after I've
have
used them
to-
for a bit.
You don't have to feel a difference introspectively. It wouldn't look any different in the output representation. It would just be that when you see a new mug, you know, like when you see a mug with a logo, you don't have to relearn the handle, you know, to look up the predicted features from the model you
Right,
already.
but let's say I've learned these two mugs, one's taller and one's shorter. And now I see the bottom of, and I have both of these, I use them all the time. And now I see the bottom of a mug, and I can't tell how tall it is. Do I say, oh, until I know better, I'm going to assume it's a short one? And now if I see it's tall, I'll change my opinion? Or do I just say, I don't know yet. I don't have enough context. You know, it's like, is there a default in this case that it's the shorter mug because that's the one I learned first? Or is there not?
Yeah, I wasn't thinking of it being like an inference default, like saying, I assume I'm gonna see the default. Like I would say inference still doesn't say, oh, I assume to be in state 0, and only if I see something that contradicts with it, I'll look at the other ones. I would still do inference over all of the states, testing them all, but for learning that we have a place where kind of the generic features are stored, so we don't have to relearn them for every variation. And then the variations just express what's different from the generic version.
But that sort of goes counter to what you just said a second ago, which is like, if wouldn't inference make the assumption it's the default scenario? And I mean, until I have any kind of contrary evidence, I would
Well,
assume it's the base model.
it would just be that if you're at a specific location in that shared reference frame and your current state doesn't store any feature at that location, it would look up what the generic model stores for that location.
Right. Well, I guess, I mean, this could be right. I like it feels more powerful and more orthogonal and more elegant. And I can't put my finger, I'm trying to come up with examples to prove that it's important. And that's they came up with examples of the two mugs, because I don't think one necessarily has a priority to the other. Why would one require a context variable and one doesn't? You know what I'm saying? It doesn't feel right to me. So I'm trying to make it work where it's to me, it's more elegant if I can just assume that all the models end up being equal. And it may not start that way. You might learn one first, but it just, and these models can grow and become independent. They can grow any way we want them to grow. The different variations of the same reference frame.
I mean, with the example, I almost wonder whether when you see that mug that's a little taller, your brain, like you potentially infer, oh, this is kind of similar to the column, to the mug I've had before. So you kind of activate that reference frame, but then with some context that, okay, this is different, you learn that there's some variation. So in some sense, it is kind of like, this is kind of a child or whatever of, or not child, but kind of a variant of a familiar object. Whereas if it was a totally different mug, you wouldn't recover that model in the first place, and you would just learn it as an entirely new model.
I thought, I'm sorry.
Yeah, that's okay.
I had a thought.
Yeah, it just okay.
Imagine
Yeah, it
I
just feels
have,
to me like you could. Yeah, it could be.
it could be which way? Are you going for the primary? You guys both like this idea of a primary model. Imagine I have.
I mean, I agree. There's weird things about it, but anyways.
So let's imagine I have three state variables that are coming from elsewhere, A, B, and C. And I learn, imagine you start off, I'm learning a new model, and I'm going to pick state variable A. So not only am I learning all the features of the object, but I'm learning them in the context of A. Now and now I learn a variation of A, the new mug, and I'm going to have a state variable B. As I move over the new mug, the taller mug, I will be I could be associating state variable B and A with the common features, but only state variable A with some features and only state variable B with other features. So
but then don't you have to relearn the things? Because
no, I don't have to
if
relearn
you
I don't have to relearn anything because there's already something there. I go to this location, there's something there. And now I can associate that something with B. I mean, it would. All right, I guess I'd have to think this through more carefully here. All right, maybe we can leave this
unless like A is always active, and then the question is,
Well,
what is
that's-
the
I'm
purpose of
thinking-
A?
Well, that's what I'm thinking. A could always be active, and A and B can be active simultaneously. All right, I think this is a tricky one here. I'm running at my limits of being able to think on the fly about this. I'll just state that it is more elegant in my mind if we do not consider this a primary model and submodels. They could start out with one you learn first, and then you learn subsequent ones. But in my mind, it would be a nicer solution and probably less likely to cause problems in the future if we didn't have to assume there was the default, mama papa object, parent, default one. It just feels like the world is always changing and morphing. It would be much easier if we just made no assumptions about there was original and now there's variations. You can just have all variations from the start. And the only thing that's common between them, the thing that's common between them all is the anchoring the reference frame. That seems to be a less problematic and more or elegant solution to the problem.
But
But I could be
Yeah,
wrong.
I mean, I understand your just a quick or like feeling of disquiet, but I guess if there's one thing that might help is just whether this sort of default model, rather than being like state A with capital A and therefore it's special, all it is the representation that exists without state. So it's the L4, L6
Yeah.
coupling and all that.
I
And
got
so
it. I got it. But imagine now, okay, imagine that's the case. Now imagine I'm learning state B, right? So I'm going around, there's some changes now under state B. And I go visit the location. So I have the state variable coming in from someplace that says B. And now I go to the default model and I'm looking at those. Well, the state variable is still there. Why wouldn't I associate the state variable with that previously learned feature?
Well,
from
isn't it
state
kind of
A?
optional context on the apical dendrites?
Well, but it would be there. I mean, it's context, and the context doesn't know when it's supposed to be applied, when it's not supposed to be applied. It just says
Wait.
there's context.
You would only apply it if there's a prediction error from the default model. If you can already make perfect prediction about your sensory input using what's already stored there, you don't have to learn a conditional different feature there.
I'm not sure that's true. You don't have to learn it, but you could.
But you've
Um,
already learned it.
I know, but I don't associate it with B. I'm only, this is the way that, what if if there's context, I always associate it with whatever I'm learning, or whatever I'm experiencing. And so imagine, neurons are always learning all the time. Imagine they're not learning only when there's an error. Imagine they're always associating context with the current observation. So that way, the context would eventually learn to predict the entire object, independent of, I'll just leave it with that. It's like I could constantly associate whatever I'm observing with the current context. And if I've already learned it, no problem. But if I haven't learned it, I'll learn it. And therefore, the context is not just predicting variations on the base model. Over time, the context would predict the entire thing. Again, I'm just trying to get away from the idea there's a base model.
I guess
And
I'm
maybe-
just not understanding what the issue with the base model is. I thought it was a really, really nice and elegant idea that way, because then we don't have to relearn any of the common features.
No, nothing has to be relearned. I'm not suggesting anything has to be relearned. There's no relearning going on here.
But you have to associate the new state with all of the different locations.
Right, but that's not learning new features at locations. That's just associating a feature at a location, which is already learned, with associating with the context.
So if context A is learned for all locations in the original kind of example, then presumably it kind of needs to always be active when we're recognizing that object, including variations. Otherwise, we need to relearn things.
I can see where you're going here.
And then it's like, well, and then it's
Okay,
not clear to me what it's always active, and then it's.
Okay, I agree that we don't want to relearn anything. So I'm not suggesting we're relearning anything. I don't mind learning associations. That's not relearning. That's just like adding on additional information. And so the question is, can I get this idea that I have, which is there isn't a parent or base object? Can I get that to work? I also like the idea that there might always be context. That is, there might always be something from someplace else giving me context. That's nice too. But then I have to decide when to provide context and when not to provide context. If somehow the mechanism of providing context was always there, it's always available. Like time might always be available, and I can use it or not, depending if it correlates. So I like those ideas. So the question is, can you get it to work?
I wonder if it's a language thing, because would you agree that there's a base reference frame?
Right, for all of these, the same reference frame.
Yeah, so I feel like that's maybe what is the base model in.
Well,
maybe in
no, my
head,
point is,
or at least
my point
yeah.
is, no, my point is the base reference frame can represent multiple objects all within the same class. That's my argument. All right, there are multiple objects under that base reference frame. So the reference frame itself does not, it can look like it's anchoring to an object, because maybe there's only one object, you know, but I give the examples like when a rat goes between rooms, the grid cells re-anchor, right? Well, my point would be like, what if I went between two kitchens or, you know, two similar rooms? Would I re-anchor, or would I say, oh, this is a variation of a one I already know? I would assume all the knowledge I have about kitchens would apply to this one. So I may not re-anchor, but I could end up learning different features at different locations.
Okay, yeah, well, and so I guess something like a base model could be what is learned in the reference frame when you don't have any specific context.
Right, and I'm
so,
trying to get away that. But the reason I got to this, the reason I actually brought up this idea initially, I said, why wouldn't I have context? Wouldn't there always be, you know, it'd be easy to say there's always some context. Imagine there's always some context. And so that seemed like, okay, that's an idea I liked, or at least it was an idea that is intriguing. It's like, then I have to worry about when there's a context and when isn't there context. It's like, there's always a context, and how I learn these objects, the order I learn them isn't really that important. You know, I could go and it doesn't really matter. In the end, I just end up with a bunch of models all under the same reference frame anchoring. And it doesn't matter which order I learned them in. They're all you're gonna end up with the same thing. There's advantages to that.
Well, what if there's always context, but there's still a kind of base model that is all the features that are generally predictive for all of the models. So you might not ever see that generic object itself, but it's kind of like maybe an average model of the other, so that whenever you don't store a specific feature in a model, you can go to that base model and use that feature to make a prediction.
Well, that's what you're arguing. Isn't that the same thing you've been arguing?
Yeah,
about?
basically you're saying you need some place to look up what to predict when you haven't stored something at that location in the specific state. So like, for example, trees. There are tons of different kind of trees, but it feels like we have some kind of generic idea of how a tree looks like. There's a tree trunk and branches and stuff like that. And we might have never seen that generic tree ever.
Right.
But we still have that to kind of make a general prediction about where the trunk should be and where to predict the greenery.
Okay, so how does that relate to our conversation? That sounds good, but
yeah, I guess just that there should be some way to look up features at location.
But that's the case. You just said yourself, there's an
Yeah,
example where I may have never have learned the base model.
Yeah, I'm
Right.
saying there should still exist a base model.
Yeah, and it could be kind of averaged.
Right,
Yeah, over
I would rather
experience.
that. That argues in my direction. That's saying I learned specifics and specific models, and then they're all in the same class, and somehow from that I can derive a generic sort of tree. It's not that the generic tree is the first one I learned.
Yeah,
Right,
I'd be okay with
that's what
that.
I was trying to say as well, that it's not that it's the first one. It's just it's kind of the accumulation of experience that yeah, like Vivian says, when you don't have a specific prediction, this is kind of tells you what you're likely to see.
Um,
And it can be reused. Or most of the features at locations in that model are reused by the different state examples. And in practice, it would look like the first object you learned when you first learned it, but over time it would change and become more kind of a general, non-specific model.
And is this like an average? Is this like the mean or the mode of what you're seeing? Is this like an average, or is it like something that you've seen multiple times?
I think it's more so I feel like what Jeff, you might have written this in the on the talk, but like we're always learning compositional objects that never stops. So like everything that we learn is probably something specific. Like we say generic mug, but like what is exactly like a generic mug? We might have never seen that. But then somehow we have all these like kind of different models of mugs with logo, mugs with chip. And the reference frame itself is like representing that class. And so I feel like that generic mug is kind of like that reference frame that's representing the class that we're able to kind of deduce from the specific that we have seen.
Getting close, but the reference frame itself can't represent the generic mug.
Right.
It's got to be a model within the reference frame. It's got to be features
Right.
associated. Well, I think
But
the tree, this example is a good example. I mean, in some sense, I think it's arguing in favor of what I'm suggesting. We learn specific things, and there's no preferred. I'm trying to make it work so there's no preferred specific things. So it's the first one you learn. You may learn one more than another, but the order in which you learn them in this class in the end shouldn't matter. And then so the idea that there's a generic class of tree that comes out of this, which is still fuzzy in my mind, which says, hey, there wasn't a preferred tree. There's lots of models of trees and under different contexts, but somehow we're able to come up with this average or mode or mean, whatever, for the whole class. That's an interesting idea. Yeah, it's an interesting idea. Well, if I could get the idea that there's no, if I could say, hey, we learn a first object, but it really has no, I can get it to work. Imagine if I could get it to work that after I've learned 3 variations of something, there is no master object anymore. There's no default object, and it all works. Would anyone have an objection to that? It's like, you're
No,
objecting to something.
yeah, I'm not arguing against that point at all. And actually, it's easier to think about a solution now that I know what your problem with it is. I'm just trying to find like a practical way of achieving that without having to relearn all the points in the new
All right,
state.
right. Well, assuming we're not going to relearn all the points. So, if I approach a problem like this, I'm thinking like, oh, in my mind, there's definite advantages to not having sort of the default object. And those, well, I should say there are advantages. It's hard for me to put my finger on them right away, but I smell that there's really big advantages here. This is somehow in the back of my brain going, yeah, you want to go this direction. This seems to be the right direction to go, that there is not a default model. There is the first model, and then we change after that, but it shouldn't matter the order in which you learn things, and there shouldn't be some sort of preferential model. If I can get that to work without relearning anything, that feels better to me than taking the simple, what seems like a simple example. Oh, we learn a model, and now we're learning and that the first thing I learned is always the parent, and now now it's all derivatives from that.
Yeah, no, I agree with that.
I think the average
Yeah.
approach could actually be a good way to achieve that. I don't know if that language works for you, Jeff, but maybe for Niels. Uh, if you think about the constraint object models that we have in Monty, where we're basically taking the k statistically most frequently observed locations, and we kind of average features that were observed at those locations to learn models. The way I would think of
Is
implementing
that
it,
to get around noise? Is that to get around the issue of noise or sampling size, or what's the purpose of that?
yeah, well, not. It was mostly so that like there's actually a point to learning hierarchical models, and we don't just learn like a super high resolution model of a house, basically.
Yeah,
That we have some constraints on the models. We can't just store millions of points for an object.
Yeah, it's kind of a form of
Okay.
sparsity. It's basically like we have a certain
Okay.
amount of representational capacity. What is the
Exactly.
best way to distill down what we've learned?
Okay.
And
Okay.
it does feel like, yeah, if you showed that
It's
a bunch of trees, it would
yeah.
develop kind of an average tree model.
Yeah, so basically there would be like the base model that always gets all of the observations, even if there are different states of the object. It always incorporates all these observations, and it learns over time an average of those. And then there's the state conditioning, which only learns the specific features on that specific object. And it would only store those features if they deviate from what's stored in the average model.
Okay. So I that all sounds good, except I still think I don't mind. I like the average model idea. I just don't like that there's a default model. I think I
Maybe
just don't like
default is
that.
the wrong word. It would be the place to look up which feature to expect at a location if there's nothing stored in the specific state model.
Yeah, I guess I'm saying I'm
And
to
it's not
me.
necessarily a model you would ever see, or like an object you would ever see.
Okay,
If
well,
somebody
it was the
like-
first one I learned, so I'm still trying to get to the point where imagine
Wait,
there's
say that
always-
again. It's the first one it's not necessarily the first one you learned. It when you've only ever learned one object, then the default model, the average model has nothing else to be informed by, so they
No,
will
no,
look
not the
similar.
average model, but I don't mind the average model. I like it's the default model I don't like.
Those are the same thing.
Uh,
Or I'm not sure what default means in this context.
it's the default means like without a context signal, what do I assume is stored?
Oh
Yeah,
no,
what do you
so we moved. I moved away from that, basically saying there's always a context signal, but we have the average model to use to make predictions when we didn't store specific features.
Oh, okay, all right.
Other
Well, that may
context.
all right. So that may be. that may be meet my criteria.
I
Right.
mean, personally, it still feels like you could have an example without context, in which case you could use the
no,
average model, but
maybe, but imagine this context. We haven't really defined what the context is and where it's coming from and how to interpret it. And when, so to my mind, it's like, well, when would there be context and when would it? If I assume that there's always some kind of context signal, because the state of the brain in some sense is context, then that's a nice idea. There's always context. There's something floating on layer one always. Something's going on someplace in the brain, and let's assume that's flying by my layer one. If I can associate, if I just assume there's always some sort of context, that seems like a safer assumption. And then I just work with that. I take that as a given. There's always context, and maybe it's useful, maybe it's not useful, maybe there's associations, maybe there's no associations statistically, but there's always context. And I don't like the idea of like, oh, we have the mug, and now under the right context, we predict the logo. Well, I'd rather have
more like we have the average mug for all the points that are not the logo to predict like the handle and stuff.
Okay, but I think that's a good compromise that might work, right? And initially the average isn't very interesting because I don't have enough to average. So initially the average will look like the first thing you learned, right? And so that can fool us thinking, oh, that's the default model. Well, in average, it's just an average model that hasn't averaged anything. So it's just
Yeah, I mean, as soon as you've seen 2 instances of that object, the average is something that you've never seen before. Right. It'll be similar
assuming
to
there's a difference. Assuming there's a difference at that point. I don't know what it means to average, like an average, like there's a logo here, there's not a logo here. It doesn't seem like you can average that. You could average morphology, perhaps.
Can I maybe show something? I remember presenting this before, where I talked a little bit about like a generic morphology in the columns and the variations in the variations in the actual SDR.
I don't remember this, but I remember the picture, but I don't remember the context of what it was. You just walk us through it.
Yeah, it was mostly that I was thinking of coming up with an average of these more different instances of the cup as a generic model, and that generic model would be in the columns themselves. So it'd be so we would have a location and a variation of that location that is an instance of that location, basically, like a unique and a generic representation. The generic being what defines the class of the objects, and it would be something like an average. And then the unique representation would be in the SDR, and it would define the actual representation. This is kind of like the state. Basically, that tells you where that actual location is based on the state. But it's the full SDR now.
Seeing this helps me realize that the different models that could be under the same class may not look at all like each other. Like these mugs they're not too far variations from each other. But the way I've been thinking about it, you can have a reference frame, and the different models under that reference frame could be really unique that you wouldn't want to average them. That would that would mess things up. Here you could average.
I guess it depends on how we're approaching class. I've always felt that there's class that's kind of more morphology based, and then there's class that's based on other things like affordance or language and stuff like that. And so like a banana and an apple both being fruit is, I think, represented in the brain in a very different way from these mugs being similar objects.
Yeah. Well, I agree, but I still think even simple morphology could be quite different. We're seeing a hint of that with the stapler parts. you know, if the top of the stapler and the bottom of the stapler are both in the same class of stapler, then you don't want to, you know, they're really unique, and you don't want to average them, but they could be very unique. You don't want to average them. I think the averaging works really well on a particular class. Oh, so a little confusing.
Well, kind of reminds me of
Yeah.
the shape skeleton stuff, kind of going back to that, which is that there's, you know, the shape skeleton being this, you know, particular computer vision type thing, but if you just imagine that the brain is doing something kind of similar where it's saying, okay, here's some underlying structure that's more fundamental to the thing. And yes, the variations, like surface level variations exist, but somehow there's some column or some part of the column that's representing some something kind of fundamental about the overall shape of that thing. And it's kind of running concurrently with the part of the brain that does the more
but-
specific surface level
Well,
variations.
but I don't know how what I mean. There's some part of the brain. I mean, it's like I'd like to understand all this in the sense of a cortical column, and like, oh, these guys over here doing shape skeletons, and these guys over here doing specific models. It could be like that. It doesn't seem like that to me. Well, I'd rather not go there. Now the more I think about it, it seems like this idea under class that there's lots of things that we might be able to observe the similarities between two objects and put them in the same class, but they can be quite different, and so averaging them isn't always going to work very well. It would make a mess of things at times.
I mean, at least mathematically, there's ways to, you know, besides average, like we can try to factor out, like, let's say we have specific instances of objects. You know, if we, I mean, so again, this is just purely mathematically, like if we have some matrix of all the points and, you know, some features, like there will be some way amongst different matrices to find some commonality so that
Well,
every
it's like
example.
it's a clustering problem, right? It's like you
Yeah,
say
yeah.
there's a lot of
Yeah, so
there's a
it might
lot
not
of
be
variety
average, it might
here.
be some other linear combinations of stuff.
Clustering is averaging over n clusters, something like that. I don't know what you call it, right? Clustering is, oh, I got 5 clusters, therefore I have sort of n averages, which could be happening, you know.
In what
Yeah.
examples are you thinking that very different models would be under the same object ID? Like,
Same object, you mean same reference frame?
yeah,
I didn't say same ID. I'm only talking about anchoring reference frames. What are you saying? What are examples where you have different objects under the same reference frame that look quite different?
yeah.
Well, even something as simple like mug morphology, right? There's a lot of things that I might say are mugs that if I averaged them, imagine I had tall, skinny ones and short, wide ones. You know, if you average at points, you'll end up with not like something in between. You know, imagine I have tall ones and short ones, and there's a lot of points that are average points, but they don't exist on any mug. So,
But if they are too different, maybe they are just learned as different objects with different reference frames. Like if you have like a tea mug and a big coffee mug, they might just be different reference frames.
Well, right. But then, I mean, so right today we're exploring the idea that the common reference frame is a way of grouping objects together under some class or some class. That could be wrong. But if I go with that idea that the reference frame anchoring represents a class, then that class should be able to accommodate lots of different things that are morphologically different. It's just I can say this is in the same class of objects because maybe it works the same, or maybe it has the same color or something, and yet
But yeah, like the object being in that class, the class needs to have some predictive power for that specific instance for it to be useful to be in that class. So it needs to share at least a good amount of features at locations with the other objects in the class. And maybe there are different models in different areas, like they might be the morphology models that share morphology, and then there might be more like semantic or action-based classes that don't
I
learn
could,
so much about
you know, I can see that objects could become quite different morphology, even though they're in the same class. Like, you know, imagine like the stapler top coming up, and as it comes up, it goes through some sort of weird gyrations, and so it ends up with a morphology. It's completely different than it started with, and yet I still know it's the same object. And I still know it's part of the stapler. You know, this idea that the common reference frame represents a class may not work out. I don't know. It seemed really good. Liked it.
I think there's another nice thing about it, which is sort of in the unsupervised learning stage. If most of the time I see mugs upright, they're mostly sort of in the same basic orientation, and that probably helps me merge them into a class. So the fact that there is something about their reference frames are already kind of aligned helps me merge them into a
Right.
class. So
Yeah,
kind
well,
of
I think
goes
that's true.
on the learning side too.
Right, right. If I see a new object and I want to put it in an existing class, then you definitely want to have similar features and similar orientations, right? Then they have to have a commonality. If I say, here's a new thing, I don't know what it is. Right, it has, then if it
But
has to have some similarities.
there seem to be two different signals or two different ways to put things into the same category with different states. One is similarity, like morphological similarity, like the different mugs. The other one is time, which is all the object behaviors, where we know it's still the same object because we've seen it transition from one state into the other. And it seems like with time, because we see the transition happening, there can be a lot more change in the morphology, and we still keep it as the same object or in the same reference frame, but with different states. But if we don't see the transition happening and they're actually different instances of objects, it seems much harder to say, oh, this should be in this reference frame, even though
Yeah,
it's
right.
totally different.
Yeah, I was trying to imagine someone saying to you, you give, you know, Link something, you say, Link, I know this looks like a teddy bear, but it's actually a mug. See, it's a mug, right? So what would you say?
Gaslighting your child.
Well, maybe it's a teddy
For
bear that's
science.
a mug in the shape
science.
of a teddy bear. I don't know. But then you'd have to you're right, you'd probably have to see like, oh, there's an opening and there's liquid in it or something like that.
There's also affordances. We put things in a specific category based on the affordances, and they could be completely different morphologies or features.
yeah, that feels more
Right.
kind of like a
Well,
behavior model. So it's like
but
a a chair or something. It's like something that you
But
can
can you have
imagine
affordance? Can you have affordances without some similar morphology? It seems like you have to have some
I
commonality.
mean, I think they
to
could be
not-
linked. Like you could learn that, chairs have the behavior that you can sit on them, but they also tend to look like chairs. But you could also kind of independently be like, oh, that is going to be sufficiently chair-like for my purposes right now.
Or just basically things like things that could be eaten, or like fruits or something, and they have completely different morphologies, like a banana and an apple. I know it might not be affordances, but it's like they appear in the same context together. They're in the same fruit basket, so you basically label them together as the same category.
Yeah, hearing this conversation made me think of something that was worth throwing out. I think about the chair example, or there are things that there are objects I have, and I know what they are, and then under certain contexts, I want to use them for something else, like a tool, or like it's something that's not a chair, but I want to use it as a chair. I know it's not a chair, and so I have a model of this thing. It's not chair model, it's something else, and but I want to use it as a chair, and so it seems to be somebody like it seems like you have to take two models. You have to have something like a chair model, and you're trying to apply the chair model to this other model. It's like you're saying, hey, here's some predictions from model A, which is a chair, and here's some affordances or some behaviors of model A. Let's see if I can make it work for this model of B, which is not a chair. And So I don't think B is a chair. I might use it as a chair, but I don't think B is a chair. I'm not going to relearn B as a chair. I want to be able to make predictions about it, like, oh, can I sit here? Will I be able to lean back on this? There's a cup holder. I don't know. Whatever it is, I might want to say, I might want to take knowledge about the chair and try to force it onto this other object to see if I can get it to work. Which is I just think that's an interesting observation. We do that all the time, I think, when we're
Right.
using tools and stuff.
Yeah.
And so it'd be like saying, okay, I don't want to relearn the non-chair object. I don't want to relearn it, but I want to be able to use it as a chair or use it as something. And I'm not going to relearn it. So I basically then have to be sort of taking one model and forcing behaviors and morphology predictions onto another model.
Or
I don't know.
we can take the model of our body and run a quick simulation of sitting down on the thing without going directly from chair to chair model. Because that feels like more like what I do. Like I think about,
Just
oh,
do it.
if I sat down on it now, would it become like, I don't know, it feels like I'm kind of.
All right. Well, that may be true of chair, but I also think like sometimes I'm doing some work on something and I need a tool. I don't have the right tool. So then I just start rummaging around looking for something that might work as this tool, what if this could hold this,
It's like we're computing similarity along a specific dimension, because similarity is a very high dimensional thing, and it's like we're singling out or attending to only one dimension in the similarity space, and we're just computing similarity between objects.
But yeah, I guess in a way that can kind of generalize to like a totally novel situation. I think using that kind of structured representation, like kind of simulation, because it's like you can see some, I don't know, like a penguin-shaped statue or something, and it's like you will have never computed the similarity of that to a chair. But if you can just kind of mentally imagine sitting on it, or I don't know.
Well, it's almost like, imagine, it's like somehow I take a chair object model and I say, all right, there should be a flat surface, horizontal surface about here in my chair model. And can I project it onto the reference frame for the penguin and say, is there some flat surface like that there? Or where is the flat surface? God, it's amazing what the brain does. It's so damn complicated, it seems. But we do this, so we know it has to happen. I think this issue of the chair examples that's actually really core to what we've been talking about here. It's a way of taking a model and using it in a way that without relearning what the model is. Right? It's in some sense a way of sharing knowledge to a new model without relearning the model.
Yeah, Misha, I saw you posted some interesting questions and stuff. Feel free to definitely jump on the call if you want to voice those, or we can discuss them.
Did you just post those now, Misha?
It was in the chat.
In the chat.
But it was in the midst of heated discussion.
Oh, there we go.
Yeah, I just I'm driving, so I never.
Okay. Yeah, no worries. I can also read it out for you if you want.
Sure. Yeah. Thanks.
Cool. Yeah, no worries. Yeah. So yeah, Misha, I guess first we're just making the point that kind of we were using this term averaging, but kind of generalizing is maybe a better kind of conceptual.
Why is that? I don't have an objection to that, but I don't know why.
I mean, I can see, I guess, the argument that, well, or I'm assuming what you meant, Misha, is like what we're kind of describing as a model that generalizes across specific instances.
Yeah, I mean, averaging just has this mathematical or morphological connotation where which Jeff, you pointed out that you don't really want to average completely different morphologies of things that still belong to the same class. But I think it's appropriate to think of it as a general, like the idea of many trees and what a general concept of a tree is. That's
so the nice thing about averaging is it is a specific mathematical thing, but generalizing isn't, I think. So I think maybe what can I say? What you're saying is that it's probably not averaging, but we still have to come up with some sort of generalizing mechanism, which we don't know what it is yet. Would that
Yeah,
be fair to
exactly.
say?
Yeah.
Okay.
Yeah, and then
It's
I
a
guess
vote
like
ag-
you said,
it's a
Jose,
vote
like
against it's a vote against
Yeah.
averaging.
I think kind of what you were getting at, Jose, was the things like, I don't know, PCA or whatever is kind of an generalizing of kind of a distribution of points. And I think already the grid constrained models that you implemented, Vivian, it feels like that already does a pretty interesting one that goes beyond just averaging, because
Yeah,
there are points in the code that averages are taken, but that isn't the key. That isn't the key part. Most of it
it's
is about,
only local averages
right,
within
most of
the
it is about
cells.
kind of storing points. And yeah, it would almost be interesting to throw a bunch of tree images
It's
at it and see what it learns.
Yeah, I guess at the global scale, it's really like K winners of like the most consistently observed locations. Um, so
Yeah, so
I
it's
guess
kind of a morphology
yeah, like it
specific
would
thing.
never if you've only seen point A and C, it wouldn't average it to B. It would pick A or C depending on which one was observed more often.
Right. But then if you had like I don't know, a crescent shape, you had lots of observations along that, and then a few that kind of went off the crescent, because most of them fell along that crescent, that would be kind of what comes out. And so that's where, yeah, it feels like it would kind of have like a lot of trees are bent and all this stuff, but most of them have kind of a roughly upward trend. And so, yeah, you would get
Yeah.
that kind of
The more I
coming
think
through.
about this, the more I feel like this averaging tree thing isn't really right, because in fact, what kids draw, they draw like a little lollipop, right? They stick a little thing on top. There's actually very few trees that look like that. Even anything look remotely like that. They're really different than that. So there's some trees that are lollipops, but so I'm wondering if maybe what kids draw is not some average. It's just somebody showed them a tree, like, here, draw a tree like this, make a circle on a stick, and that's what they learned.
Yeah, it's also difficult because when we talk about what people draw and what children draw and stuff, it's kind of entangled with what your internal representation is and what you're able to produce,
Yeah.
which aren't the same thing. And we've
Right,
talked many times
right,
about how people are terrible at drawing and all the different
right,
reasons Thousand
right,
Brains theory might explain that.
right. But
Um,
anyway, I think this, I'm not sure I buy the average thing. I mean, or even the generalizing thing. I feel like, maybe
Yeah, I
kids are
mean,
just drawing.
yeah, I think the statistical frequency thing is probably better than averaging, but another thing we could look at is like how predictive it is for the different instances of the model. So we would only store points in the general model if they are kind of consistent with most of the other states. Because like there's no point in storing a point in the general one if all of the specific instances overwrite that point with a different
Yeah.
feature.
Yeah, between us, I'm not gonna think about this averaging thing. I think might be a bit of a red herring today. And I'll keep it in the back of my mind. But I do think,
But not in
it's
general, because I feel like it was the only solution to not having to relearn everything. Like taking
what?
out of the equation how it's generated, like I agree it might not be an average, but that there should be some kind of generic representation that we can look up the feature if we don't have it in a specific model.
I don't know. I'm thinking of the tree example. I think kids learn that's how you draw a tree, not that they observe trees and then generalize
I
that.
agree with that. I mean, I'm not talking about drawing. I'm just talking about like
Right.
how would you learn them without having to relearn all of the points in the different states.
But how to learn what? The
Like how do you learn
uh,
a new state without having to relearn all of the points
well,
if
I
you
thought
don't have a generic model to look into?
well, I think that was the key that I'm going to walk away trying to solve, which is imagine I don't have a generic model. I have a bunch of models, each have its own context, and these models overlap. So many of the models have the same features at certain locations, and so the assumption is we never have to relearn. The knowledge is there. And the question is, how do I make sure I use the knowledge that's already been learned fruitfully? I'm just taking that as the working assumption and the task to solve. I think it can be. I think it can be done without a generic or default model.
So you would just look up in a random other state?
No. You have there. Imagine every location. You might have something stored. You may not have anything stored. If you have something stored, there could be one thing, or there could be multiple things, depending on the context. And we just take that as a starting assumption, right? So if there's something was learned at some location, it'll be there, and it might be consistent with one or more contexts. And if I'm on some context and there's a feature there, and my context is not associated with that feature, well, then I would associate that feature with my context.
What if you're in a context and you haven't stored a feature for that location?
And there's still a feature stored there. Just my context doesn't predict it, but there is a feature there. The feature will be. Imagine I can recognize a feature with the context is an optional override, right? So it's like, imagine it's coming on layer 1 or something like that, and there's things learned there, but I can now. I guess it would default to one of the other states. I guess whatever learned one of those. I don't have to make it work.
Yeah, that's that's I feel like the core problem I was trying to solve today, at least. Like, what state does it default to?
I don't know. Okay. Well, now that I have a clearer definition of a particular problem, I'd like to think about that.
If there's no general model, then how do you, like, what do you do when you're asked what is above the tree trunk in a tree? How do you answer that question if you don't have a general model of a tree?
You have models of trees, right? So there's no question. You have knowledge about that. It's just you're asking me. You're assuming there's a general knowledge as opposed to a specific knowledge. I mean, I could learn one tree. There's only one tree in my life. I have a very impoverished place I live. There's only one tree, and I could learn that tree, and you can say, "But what's above the tree trunk?" And I can tell you. I don't have to have a general model for that. Yeah, and then there's a lot of trees where you can't even answer that question because tree trunk is invisible. It's hidden behind,
But like you're looking at a new tree and you recognize it's a new tree because the trunk at the bottom looks different. So you have a different context now than from what you learned before in the tree class. Now you look up, you can still make a rough prediction that you're gonna see some leaves there.
Just because I have a new context doesn't mean I'm trying to get to the point where I have a new context, but if my context doesn't say something about a particular point, I'll default to something else. I'll default to whatever else is there.
Okay, so then, yeah, I'm not sure.
The question is, you want to default to the default model. I'm trying to avoid having a default model.
Maybe
So,
one
but
thing
where would you
that's
default to?
maybe that one
I
thing
don't
that's
know. I have
worth
to figure
bringing
it
up,
out. You guys, let me work on it.
because it came up at the end of your document, Jeff, and also I think it was kind of what your other question was referring to, Misha. We can also have columns with different models, and so you can have a column that has learned a kind of more coarse model of trees, and so it's kind of closer to the lollipop representation, even if it's not necessarily that. And that might be through kind of sparsity constraints about trying to learn like a complex object, but without that much kind of representational capacity.
Maybe.
Or it could be through having large receptive fields that are kind of blurry input features and things
Maybe,
like that.
but with specific example of the tree, I've argued that we don't really see trees that look like lollipops. Very rare. So
right, but you might have a column that only looks for green blob, not green blob, but it just looks
I'm
for.
just saying, yeah, I'm saying I don't think that I don't even see that really in nature. Again, I'm going to go back to the tree example. Maybe your point's still valid, Niels, but the specific tree example, I think kids draw the lollipop because that's what they're told how to draw.
Sure.
It's like, that's
yeah,
not what they don't see that anywhere.
But then I guess circling back to kind of the motivating problem for this was kind of, okay, we know a model of a mug, now it's got a chip in it or something like that. How do we represent that, be able to predict that without having to kind of relearn the model of the mug? And one valid approach, which you discussed in the document, Jeff, is kind of maybe you have different columns that have different models, and one of those columns or some of those columns do update their model, but then other ones keep them the same.
Well, that would be true certainly if different modalities, for example, one has a color spot on it, you wouldn't feel that. You would just hear, but I don't think that's a general solution. I just missed that in my write-up.
Yeah,
it's
I mean, I'm just saying
got problems.
Yeah. I'm not saying it's the solution. I'm just saying it is like another one to, I guess, consider. But yeah, I think
here's another way to think about it. All right, and maybe I'll try to solve this problem the way I want to solve it, and I won't succeed, so that's fine. But I'm going to try. One of the things I realized that in terms of providing context, we really don't have any good. We're just throwing it out like it's something, but we don't really have a good example of or a good understanding of it. Like in the staple example, the context there was masking that went along with it, or something like that. Maybe the solution to this, what I'm trying to achieve, is having a better understanding what context is.
Yeah, I feel like maybe we have two examples of that, what it could be already. One is the feedback connection to layer 1 that could give a context signal. The second one could be the time signal in an object behavior. Those won't really work for like object categories, like which type of mug instance is it, but I guess maybe it'll still help to think through some of the examples.
Right. And there's examples of context which are really out of left field. Often we have surprising predictions based on some sort of context, like, the context is something Neil said earlier today about, his house. And in that context, I make different predictions about something, I don't know, we're talking about right now. I mean, it's like, there can be or something I saw this morning on, in my yard changes what I think about something else later. I mean, context can be really all over the map. It can be very specific, but it can be really strange. And time is just like one of those, right? It's just one of those things.
Just circling back to what you were saying, Vivian. Is there a reason it couldn't be the first, the L1 feedback, that couldn't impact class? Because if L2, L3 neurons have apical dendrites going up to L1, it feels like that would be a good location to kind of influence the sort of object level description.
Right. Yeah. I think it would be part of that solution. I guess it just in my head seemed a bit of a chicken and egg problem, that the lower level is trying to tell it that it's the logo, the mug with the logo, by recognizing the logo, and then the higher level one is trying to give it the context. But I mean, we have.
I agree though. Like, because I was thinking about this before, that like, if the state or context or whatever is represented in the apical dendrites, how is that communicated up? So it kind of feels like there might be different places it's represented, or different representations of it. And one might be what is active in L2, L3, and that could be passed forward. And one is what is the feedback, and that would be more like the L6 to L1.
Maybe. Well, I'll point in general, there's a whole ton of stuff in the brain that projects to layer 1. I mean, we've talked about time, the matrix cells, other regions, weird stuff all over the place. I mean, you want to, and emotional saliency issues, that's where, neuromodulators are released often in layer 1. So,
which is perfect. It's just what we're looking for the context signal. Something where we can get a bunch of different types of signals.
Right. So you imagine layer 1 is this bath of like noise going past all the time about different things that might mean different things. Of course, the columns don't really know what most of that stuff is. It's just activity up there. But the general idea is they can pick and choose anything that's helpful associatively from up that point. So I'm just pointing it out that layer 1 has very specific projections, like we did in our paper and Neil's just talking about in Vivian. But there's also all these crazy stuff. Everything goes up there. It seems like, so, which is good, right? We want broad context, and part of being smart sometimes is to recognize an unusual context as a predictive mechanism. Something that someone else didn't pick up. So all good. Well, let me ask before I go on, we end today. If I'm wrong and let's say there is a default model, not even an average one, just like the default, like, we learned this and now we're learning variations of it. Was there any problems with that we identify? Are there any specific problems?
I don't
think so. I think the main one is yeah, how we derive it, because, and I think that's maybe what came up when you were presenting that, Rami, is that we were kind of discussing how would you kind of average the morphology points or something like that. And we were concerned, kind of like you were saying, Jeff, today, that depending on kind of what system you're using, you might end up just with like a total mess. But
but
it feels like there are many different approaches, and as mentioned
I'm
before,
not,
like the one we have is already fairly sophisticated.
I'm not excited about the averaging idea. So do we need that? Is that essential?
I think averaging is really a term worth avoiding.
Right.
Yeah, basically just a generic model.
Or kind of distillation.
But is a generic model learned, or is a generic model
distilled or
computed?
Yeah, right, computed.
No, it's definitely learned, and I feel like it has the attributes you wanted, which was like the first model you ever learn, it's going to be kind of like that. But then, as Vivian says, as soon as you learn a second model, it's going to be unlike any model you've ever seen, any object you've ever seen.
It feels more like we're extracting the variability. So it's like we're subtracting the variability from the model that we learned, and then we're building associations with that as a state. So it's exactly like what Tristan is doing with extracting a functionality from a class, and he's just assigning a default class there, and then he's just building other few ones, and then just assigning different connections to those extracted functionalities. It feels exactly the same to me. It's just like we're removing the variability, and then we're assigning it back, but as an association. And then we're building associations with different other variabilities or with different variations of that class.
Which, yeah, kind of fits with maybe the language that you were kind of using, Jose, of like maximum variance, that kind of like there's some parts that kind of, there's some way of representing most of these things and accounting for most of the things we observe, and then there's kind of slight deviations from that, and it's the slight deviations are kind of the states, and then the sort of generic description is the
I think sorry,
it's all right.
I was going to say one nice aspect of that description is that when there are areas with a large degree of variance, that's a good signal that the prediction is not necessarily strong. It's not a strong prediction necessarily. But areas where, there's a great deal of consistency, we ought to have high confidence in our predictions to locations like that.
Unless the variances are associated with very specific instances, right? If the variance is associated with very specific instances, then those are significant. That's part of the problem. When do you assume things are unique? I have one last thought before we're done for the day, if we're going to almost be done. I'm working on another idea, which is really, really confusing. You think today's confusing. But I throw it out because maybe it'll spark something. So in our models, if you think about like layer 4, the feature layer, I'm going to talk about the neuroscience now, right? We have a representation of the mini column represents like the point normal of the edge orientation, and then the cells in the column are uniquely represent specific instances of that edge, right? So it's a generic edge and then a very, very specific location, specific object. So I was wondering if the same thing is happening in the location segment. There's many columns down there. They have similar properties. In the idea that you'd have two representations of location, One is a very generic one, which is almost just like pure grid cells. There's only maybe 10 or 12 different grid cell locations that a grid cell can represent, something like that. And then there's specific, like then you in a mini column, you pick particular cells that would represent specific locations. And so you have like generic feature, which is really just an orientation, and then specific features. And then in the bottom, you'd have generic locations, which are not really unique, but still something, and then specific ones. And so when we were talking about, when we're talking about things like, averaging or fuzziness or whatever, it's just the idea that could the brain be taking advantage of the same sort of mechanism we see in layer 4? Could the same similar type of mechanism going on layer 6, where we have the generic, a very, very low resolution location and a high resolution location? So anyway, that just
So I mean, kind of like what Rami was showing before. I don't know if you remember that when he presented that, but
the one with the pictures of the mugs we saw earlier today.
yeah,
Dimensional change card slot. I don't remember seeing this. This is new to
That's
me.
the wrong one. So.
I would remember rowboats if I saw rowboats before, so I don't see a rowboat.
target, yeah.
Hold on just a sec. Something
Are
like
you guys
that.
hearing that? There's a noise outside my window. Are you guys hearing that? Does it bother me?
Okay. So
Oh,
basically,
this thing here. Oh, the generic and specific. Oh, really? That's right.
I was
I'm sorry.
thinking.
So what did you conclude from that?
So we were thinking that we would have, just like we were having in the layer 4 features representation, we'd have
Right.
and then this, and then we also suggested that we'd have the same thing in the layer 6 also.
Right. Okay.
And
And how do they proceed? What did you learn? What did you gain from that?
I don't know. I felt it was a good idea. I didn't really.
Okay. All right. So we have. I mean, I've thought of this idea before and I'd forgotten about it, and then so I just brought it up again this week in my thinking. So maybe you were thinking about it too, or maybe this is, I don't know where this came from, but yes, this is the idea. But I'm not sure where the arrows go. Like yes, you have these two representations. But where do the arrows go? I don't know how do they interplaying with each other? When when would you use a very coarse coding of space versus a fine coding of space?
Right.
We have some ideas of when you use a coarse coding of features versus fine features, right? We can see the advantages of that.
Also, I'm not entirely convinced that the generic location is actually Cartesian at all. It could be like a toroidal thing, like Jose mentioned before, where those generic locations are not Cartesian 3D at all. There's some abstract space.
Right. They would be toroidal, because just think about pure grid cells. Imagine, I'm thinking like a grid cells. Grid cell modules are, if you just take one grid cell module, it has maybe, I don't know, 10, 20 different locations you can represent, and they repeat over and over again. And so it's often described as a toroidal space. But it still would say, what it does is says that particular representation would appear many different places in the world. It's not unique. It doesn't occur everywhere. It just 1 out of 20 or whatever it is. So it repeats over and over again. Just an interesting tidbit. When when grid cells was discovered, what's his name? The guy who discovered
Edward Moser.
Moser.
O'Keefe.
O'Keefe, right? O'Keefe.
O'Keefe was place cells, right?
Yeah.
Right. He discovered place cells.
Oh, sorry.
And then the Moses discovered grid cells. And O'Keefe, they're very competitive people. and as far as I know, and Keith was some one point expressed disappointment that he didn't discover grid cells too, and the reason he didn't is that where he was looking, the grid cells, the spacing in them was so large that they didn't actually repeat within the environment. That they were representing the space in the environment, but they didn't actually wrap around the torus. They didn't repeat again, or he didn't. It was far enough apart that they didn't see that. So, which is interesting observations. It means that, you know, many times you might just have a coarse coating of space, and you don't have this toroidal aspect yet. You know, you don't have the you know, which is normal, repeating a lot or not repeating a lot and having sort of coarse coating. It just throws that out that it's still, if I don't have that, if I have a large enough receptive field for the grid cells, it's just a fuzzy representation space. It's not a it's not repeating. So each grid cell only would represent a fairly large area. So something else to think about in that picture you made, Ronnie. So
Cool.
okay.
Yeah, that seems like a good stopping point.
More stuff to get confused about. All right. Well, we'll get to the bottom of this, I'm sure.